Hey students, good afternoon, good morning, or good night to you wherever you are located at the moment and at whatever time you're watching this tutorial. Welcome back to another video lesson from the Apex Institute of Mathematics Education. My name is Akin, your math instructor. Now in today's lesson, we're going to be looking at, as you can see there by the title, multi-step fraction problems involving the use of PEMDAS. Now, in one of my previous tutorial videos, you would have seen where I explained how important PEMDAS is, not just to basic arithmetic, but PEMDAS is applied right throughout the mathematics problem applications. So it is no less here that whenever it is that we are doing a math problem that combines more than one operation, then PEMDAS will perhaps be the principle that you will have to apply, because of course PEMDAS tells us the sequential order in which problems must be simplified. Now, I'm going to be of the assumption that you guys would have already had the prerequisite skills of learning the basic aspects of fractions, such as the difference between improper and proper fractions, converting mixed fractions to improper, converting improper fractions to mixed, knowing how to find LCM, and knowing when to invert and cancel. That is me being of the assumption that you already know this. If you have, then this lesson should of course clear up and give you all the confidence to attack any fraction problems that you may encounter at the CSEC, CCSLC, SEA, EDXL level of math. Of course, if this is the first time here on the channel, do not forget to hit the subscribe button below to join the family of students wanting to become better students at math. Do not forget to also leave some comments, questions, video requests. Hit the like button, it does help the channel to grow. And do not forget to turn on your post notification bell to be notified on a weekly basis whenever I post tutorial contents. Be sure to also check in the description box below. You will in fact find lots of information, contact information, social media handles, to which you'll see me teaching lots of students, thousands, hundreds, thousands of students right across the island. So be sure to log in on those social media platforms. Let's get right into the particular focus of this lesson. Right? I do recommend also that you pause the video, you attempt the questions before watching the tutorial video, then unpause the video and try to see my solution if it matches with yours, so you can be more efficient and be more confident as a student. All right, let's get right into it. We have about 6 questions that we're going to be going through that brings out various aspects of PEMDAS and will also build you as a strong student. At the end of this video, I do hope that you shouldn't have any problems with multi-step fraction problems. Let's get right into it. So our first question here is in fact 3 4/5 take away 2 1/3, which is in a bracket, multiplied by 1 1/4. So the very first thing that we actually need to do here is in fact work what is in the parenthesis first. Now, just to point out, in the event that you may get a question in the future that in fact didn't have a bracket, perhaps like say so, then in this case we wouldn't be allowed to subtract first. We would have to definitely go ahead and multiply first, and that is if the question didn't come with a bracket. But this particular question came with a bracket, which forces us to have to subtract before we multiply, because we're then doing what is in the parenthesis first. But before we can do any form of subtraction or multiplication, it is advisable that you convert all your mixed fractions to an improper fraction. So you can therefore then say 5 multiplied by 3, that is going to be 15. 15 plus 4 is in fact 19 over 5. We're going to then take away here 3 times 2 is 6. 6 plus 1 is 7 over 3. Multiply then by 4. 1's 4 plus 1 is 5 over 4. I do recommend that you do all your conversions before you proceed. Next, since we are doing what is in the bracket first, we are subtracting two fractions. We'll then proceed to find what is known as the lowest common multiple. So we draw a line and we find our LCM. Our LCM can easily be attained by multiplying the denominators. Now, sometimes when you multiply the denominators, you may not necessarily get the lowest multiple, but you may in fact get a multiple. So if you can find the lowest common multiple without multiplying, then by all means I do recommend. But if you're struggling, then by all means go ahead and multiply. If it is that you get a bigger multiple than what is required, you may have to reduce your fraction at the end. So here our LCM here is 15. That is 5 times 3, 15. Now we divide our denominator into our LCM, or in other words, we divide the LCM by the denominator and multiply the result by the numerator. So 15 divided by 5, or 5 into 15, goes 3 times, multiplied by the top, and 15 divided by 3, or if you want to say 3 into 15, that goes 5 times, multiply the top by 5. We then therefore have here 3 multiplied by 19, and that gives us a result of 57, to which we place here on the line. And 5 times 7 is in fact 35, to which we here placed on the line. Now if we go ahead and we do our subtraction for this aspect of the problem, then you'll find here that our answer works out here to be 22 over 15. It's very important that you also check in the event that we end up with numbers that can be reduced, because if it can, it is advisable that you reduce your fraction to the lowest term, so it's easier to proceed. So this here becomes our result of the bracket aspect of the problem. We're then going to transfer this answer here, and we're then going to say here, 22 over 15 multiplied by 5 over 4. Now, whenever we are multiplying fractions, we are looking to reduce the fractions to its lowest term. So by cancelling numerators with denominators, we can actually find a factor that can reduce the 22 and the 4, and the 5 and the 15. So it's a little evident here that 2 divides into 4 2 times, and 2 into 22, 11. We can say 5 into itself 1 time, and 5 into 15 3 times. So we end up with a final result here of 11 times 1 is 11, and 3 times 2 is in fact 6. Now, we don't usually recommend that you leave your answer in an improper form. We recommend that you write your answer, your final answer, in its lowest term, which is in fact going to be a mixed fraction. So then, by extension, 6 can actually go into 11 approximately 1 time, and it will leave a remainder of 5 divided by 6. So this here becomes our final result here. Okay, that becomes our final result. Next, we move on to problem number 2, which if you look carefully, sometimes will come off a little scary. And as I said, problems like these, when I go through problems like these are for students who have been struggling with math for a very, very long time. So these are not for the advanced students per se, and advanced students will probably run through this problem in minutes. But for a student who is struggling, this is how we approach the problem. Now we have a lot of stuff going on here in this problem, and this is in fact a two-part problem. So we have to simplify the operations that are at the top of this particular problem, and then we also have to perhaps simplify whatever it is that is at the bottom of this particular fraction here. So what we're looking at here is to work out the A section, or some teachers will say the top part of the question. We have a bunch of stuff going on here, so let's just rewrite our problem that is at the top. 7 over 4 plus, open bracket. As said before, once it is that you end up with mixed fractions, it is advisable that you convert your mixed fractions to improper. So then what we have here is 2 multiplied by 2 is 4. 4 plus 1 is 5 over 2. And we're therefore then going to say take away 3 multiplied by 1 is 3 plus 1 is 4 over 3. Multiply then by, say here, 1 over 4. There's no conversion needed there. Beautiful. We're still focused on what is inside the bracket. So what is inside the bracket here is in fact subtraction and multiplication. So we already know from the PEMDAS rule that we cannot subtract before we multiply. In this case here, we have to multiply before we subtract. So therefore then, we're looking to cancel out. We do not find LCM when we are multiplying. We look for common terms to cancel, or a factor to reduce our fraction. So in this case here, you'll see easily that 4 into itself one time and 4 into 4 one time. So after that very simple and short cancellation, we end up with 7 over 4 plus, open bracket, 5 over 2 minus 1 times 1 is 1, and 3 times 1 is 3. Okay, now in this case here, I'm still in the bracket because I haven't gotten a single answer. But in fact here, I can remove the bracket because the rules for addition and subtraction are the same. So it's not going to make a difference in terms of what I do. Here's what I'm going to do though. I'm going to follow the rule, and I'm in fact going to just simply work out what is in the bracket first though. Alright, although it won't change your answer if we do the whole problem at once. So here we're going to go ahead and we're going to say here LCM is 6. 2 into 6 goes 3 times, and 3 into 6 goes 2 times. Fundamentally, you want to practice to do this, so when you become more advanced, you can take multiple steps at once. So then we end up with 7 over 4 plus 5 times 3 is 15. 1 times 2 is 2. So we end up here with a very simple answer of 13 over 6. We bring that down here and we find the LCM again. Now here's a very primary example of where we said earlier that multiplying the denominators will give you a multiple and not necessarily the lowest common multiple. Now the lowest common multiple, looking at these two values of 4 and 6, is in fact 12. But if a student decides to multiply the 6 by the 4, they'll get a multiple of 24, which can still work, but they're going to be dealing with or handling numbers that are bigger than they have to deal with. Nevertheless, I'm going to go ahead and I'm going to use the lowest common multiple here of 12. 4 into 12, say here, goes 3 times. And 6 into 12 goes 2 times. So now what we have here is 3 times 7 is 21, and 2 times 13 is 26, and that's equal to 47 over 12. This here now becomes the result of the top section of the problem. Now that we have one value or one fraction, one simplified fraction for the top, we then transfer that answer, which is going to be, say here, 47 over 12. And we're going to simply, this symbol here means to divide by the fraction that is at the bottom. Now the fraction that is at the bottom is a mixed fraction, so that will need some conversion. 5 times 3 is 15. 15 plus 2 is 17 over 5. So therefore then, what do we have next? We have 47 over 12 multiplied by 5 over 17. And then we're looking for something to cancel. Do we see anything to cancel? Well, 47 is a prime number, 17 is a prime number, 5 is a prime number, 12 is an even number. Doesn't seem as if anything can be cancelled. So then we are going to end up here with 47 times 5, which works out here to be 235. And then 12 times 17, 204. Once again, it's not recommended to leave your answer in a mixed fraction form. So how many times do we think 204 can be extracted from 235? That only seems to be about one time. So there should be a remainder of approximately 31 over 204. Now for exam purposes, you don't necessarily will get problems like these, but it does show that regardless of the structure of the question, you can get a variety of answers. So there's no particular answer that will make your problem correct. Once you have applied the principles correctly, then you should be okay. Let's move on to another problem. Now this is a very familiar problem here, and this particular problem here is also yet again a two-part problem that requires us to work out the top section followed by the bottom section, then divide both answers. But before we do that, let's of course go ahead and do all the possible conversions that we need to do here. So at the top, let's do the conversion up here. 5 multiplied by 5 is 25, plus 2 is 27 over 5. Take away here, 4 times 2 is 8. 8 plus 3 is in fact 11. So that's 11 over 4. There is nothing here to really convert, but please take note that this 4 is a whole number, which can be rewritten as 4 over 1. Take away, nothing to convert here. This becomes 3 over 5. Now once we have done that, we can then segregate our problem and work it out in parts. So let's bring this A part of the problem down here. We end up with 27 over 4 minus 11 over 4. Pardon me, it is 27 over 5. Take away 11 over 4. Once again, finding the LCM, which is 5 times 4 is 20. 5 into 20, we multiply this by 4. 4 into 20, multiply the top section here by 5. Now of course, 27 multiplied by 4, that seems to be 108. And of course 5 multiplied by 11 is in fact 55. So if we go ahead and we take away 55 from 108, we should end up with a result of 53 over 20. Now there's no point in converting that to a mixed fraction because that is not our final answer. Converting this to a mixed fraction will force us in the end to reconvert back to an improper. So we're going to hold on to our answer here as an improper fraction. Next, what we have now is the bottom section here, which is B. So then we have 4 over 1. Take away is 3 over 5. Our LCM here is in fact 5. 1 times 5, 5. Now, 1 into 5 goes 5 times, and 5 into 5 goes 1 time. So 5 times 4 is 20, and 3 times 1 is 3. So we end up with a result here of 17 over 5. This now becomes the simplified answer for the bottom part of the problem. Next, what we have then is to divide both answers. So then we're going to have 53 over 20 divided by 17 over 5. Because we're dividing two fractions, we are going to need to reciprocate. So we're going to have 53 over 20. We'll then convert our division sign to a multiplication, and we're going to invert the last fraction, 5 over 17. We're then now looking for something to cancel. So we have 5 into itself one time and 5 into 20, 4. Doesn't seem as if 17 can go into 53. So therefore, we're going to have 53 times 1 is 53 divided by 4 times 17. That sounds like about 68. So here we have a proper fraction that cannot be converted to a mixed fraction, because 53 over 68 is the lowest form. Example number 3. Let's move on then to example number 4. These are all exam structure type questions, possible questions that you will see on your exam CSEC paper. After this video, you should confidently be able to take on any particular question, fraction based, that comes on your exam. If you are so far enjoying the video, do not forget to hit the like button before you leave this particular tutorial. It really does help the channel to grow. Let's move on next here. Now, again, we have a two-part problem. But unlike the first 3 examples, or the first 2, the second example and the third example, we don't really have much to simplify at the top. We only need to do a simple conversion. But of course, as recommended, let's do all the possible conversions that is required. Let's do it to the side here. So then what we have here is 5 times 4 is 20. 20 plus 3 is 23 over 5. And all of that will be divided by the conversion of 7 times 2 is 14. 14 plus 1 is 15 over 7. Multiply then by, we're going to square this. But let's just leave that alone for now. Okay, because we're just doing the conversion aspect. Okay, so there is nothing much to do at the top. So we're going to just safely say that this is the simplified answer for the top. Let's take the bottom of our fraction here and simplify. So we have 15 over 7. Then we're going to be multiplying it by, we're going to be squaring this 3 over 4. There's a couple of ways to look at this. You can in fact say 3 over 4 multiplied by 3 over 4. Or you can look at this as saying 3 squared over 4 squared. Either ways you look at it, you'll get 3 times 3 is 9. 4 times 4 is 16. Down here, 3 squared is 9. 4 squared is 16. 4 squared means 4 times 4. So however you want to look at it, that's okay. So then we end up with, of course here, 9 over 16. We're then looking for something to cancel, but there isn't anything here. So since as there isn't anything here to cancel, we end up with 15 multiplied by 9, which gives us a result here of 135. And 7 multiplied by 16 gives us a result here of 112. Again, there is no point in converting this back to a mixed fraction because we're not yet finished with the problem. Now, since we have the answer here at the top, which is, say here, 23 over 5, and we're going to be dividing it by 135 over 112. Then by inverting the fraction and changing the sign to multiplication, we end up with 23 over 5 multiplied by 112 over 135. Now 23 is a prime number and 5 is also a prime number. 135 can be divided by 5, 112 can be divided by 2. It doesn't seem as if anything here can be cancelled. So we're going to end up with some very large numbers here. And that's okay, because it depends on the structure of the question. So we're going to have 23 multiplied by 112. That gives us 2,576. We have to prepare to work questions like these, guys, because when you get these questions, you may think you are incorrect when you're not. That gives us 5 times 135, 675. So our task here now is to try to figure out approximately how much times can we possibly get 675 from 2,576. Let's jump on our calculators, and you'll find here that 2,576 divided by 675 gives us an approximate answer of about 3. So we can get about 675 from 2,576. It's now time for the remainder. Now if we multiply 3 by 675, we get 2,025, and if we subtract that away from 2,576, we should easily get a remainder here of 551. I'm just basically showing you a technique that in the event that you actually get large numbers like this, you can easily manipulate your timetable by using your calculator. So first thing that we do is to divide the 675 on our calculator by into 2,576 to get an approximate result of about 3 point, and you're going to get decimals. By using the 3 to multiply the 675, it will give you a result to which you're going to be subtracting from 2,576. That gives you the remainder of course, the numerator over the denominator. Alright, now these questions were obviously structured by me. I just made up some numbers, made up some problems, so that's why we're getting results like these. But for exam purposes, you most likely will not get problems like these. But be prepared, we never can tell. Moving on, next, we're going to have 2 problems left here. Let's quickly run through these and bring our tutorial here to an end. Now there isn't much conversion. Let's just go right ahead and attack the problem at the top, because there isn't much to do at the top. Do reminded that whenever you see a whole number, the whole number can be in fact expressed as a fraction, with its denominator being 1, and we have 4/5. So we can get right to the problem here by simply going ahead and find our LCM. So then we have here 5. 1 into 5, 5 multiplied by the top. 5 into 5, 1 multiplied by the top. 5 twos is 10, and 4 ones is 4. So we end up with a result for the top of 6/5. As a reminder, and a constant reminder, there is no point in converting this improper fraction to a mix, because it is not our final answer. Let's then proceed to working out this bottom section of the problem here. Now we need a conversion because this is a mixed fraction. So we have 4 times 1 is 4, plus 3 is 7/4, plus, of course, we have this whole number here, which is 5, similar to that of the 2, that can be expressed as a fraction with its denominator being over 1. Our LCM then works out here to be 4, and so therefore what we're looking at here is 4 into 4 goes 1 time, and 1 into 4 goes 4 times. So we simply end up here with 7 times 1 is 7, plus 5 times 4 is 20. So we end up with 27/4. That becomes the answer for the bottom section of the problem. So now we have the answer for the top, which is 6/5, and that's going to be divided. This bar means to divide. So we're going to be dividing by 27/4. We're simply going to be the 6/5 multiplied by 4 divided by 27. As discussed, when we're dividing fractions, we invert the last fraction and change our sign to multiplication. So now we're looking for something to cancel. We have to be careful here, because if we don't cancel, we're going to end up with a fraction that is unreduced, and give or take the level of the math that you're doing, a teacher may take off mark, or they may just ignore it. Here I do recommend that you look carefully to see if anything can be cancelled. It seems as if 3 can go into 27 about 9 times, and 3 can go into 6 2 times. It makes the problem easier. So we end up with 2 times 4 here, which is 8, and we end up with 5 times 9 here, which is 45. That is an improper fraction which cannot be reduced any further. Alright, so that's 8 over 45. And now we are on to the last question. If you're getting some value, check to see if you have hit that like button, guys. Leave your comments down below. Of course, if you have any particular problem assignments, you're free to check in the description box below, where you'll find links that you get you in contact with me so that we can help you become much better and stronger math student. Finally, what we have here is once again a question that perhaps will look a little confusing, and there's some things here that you have to bear in mind because PEMDAS is very prevalent in this question. You can easily make a mistake if you're not focused. So once again, let's do all our conversions. There's a couple of things to convert here, so let's get that done first. 5 multiplied by 2 is 10. 10 plus 3, that gives us 13 over 5. Take away 2 ones, 2 plus 1 is 3 over 2, multiplied by no conversion required, that's just 8 over 9. We're then therefore going to go to the bottom and we're going to be doing some more conversion. 3 times 4 is 12. 12 plus 2 is in fact 14 divided by 3. We're going to then multiply this by 4 ones, 4 plus 1 is 5 over 4. Nothing to convert here, so that's just going to be plus 2 over 3. Now this is very tricky because if you're not focused, you may make the mistake of subtracting before you multiply. So it's very important you recognize that you have subtraction and multiplication. You must in fact multiply before you subtract. So when we're multiplying, always check to see if there's something to cancel. If we can cancel, it is easier. So we're going to end up here with 13 over 5. And we're going to be taking away the result of this cancellation. 3 into itself 1 time. 3 into 9, 3. 2 into itself 1 time. 2 into 8, 4. So we end up with a very simplified answer of 4 over 3. Then we're going to go down to the bottom to see what we need to do here. Now the multiplication appears before the addition. So once again, you cannot add before you multiply. You have to multiply before you add. So here what we have now is simply, we see that we can divide 2 into 4 2 times, and 2 into 14, say here 7. Nothing can go into the 3 and the 5, they're both prime numbers. So we end up with 7 times 5 is 35 over 3 times 2 is 6. I'm going to plus back 2 over 3. Let's take the bottom part of the problem then, and we're going to say here 13 minus 4, 13 over 5 minus 4 over 3, and the LCM here works out to be 15. 5 into 15 goes 3 times, and 3 into 15 goes 5 times. 3 times 13 is 39, and 5 times 4 is 20. So we end up here with 19 over 15 for the simplification at the top. Now let's proceed to go in at the bottom then. 35 over 6 plus 2 over 3. Another example here where if we multiply the denoms, we're going to get a multiple and not necessarily the lowest. Again, easily the LCM can easily be identified to be 6. But if you use 18, you will also get the correct answer, but you will have to simplify. 6 divides into 6 goes 1 times, and 3 into 6 goes 2 times. So 35 times 1, 35, and 2 times 2 is 4. So we end up with here 31 over 6. Now to wrap this problem up, let's take it up here. I'm running out of space, guys, forgive me. So then what we have now is 19 over 15 divided by 31 over 6. So now, as we've been doing so far, 19 divided by 15 multiplied by 6 over 31. And we're looking for something to cancel out. We can easily cancel out here 2 into 6. 3 into 6 goes 2 times, and 3 into 15 goes 5 times. So we end up with a final result here of 19 times 2, which is in fact going to be equal to 38, and 5 times 31 works out to be 155, and this becomes our final result. So this was in fact quite an interesting class, interesting tutorial. We attacked fractions of all forms, all types, all levels. We've used and showed the principle of PEMDAS, and of course cleared up any ambiguity in the knowledge of fractions. I do hope that you go forward with your fraction problems that are on your CSEC paper, and you'll be able to easily work through those problems to get your answer effectively. Do not forget to check the description box below for information, social media handles, contact, catalogs, of course, services that I offer. If you are interested in joining my online platform or my live classes, be sure to join into that by contacting me through one of those information in the description box below. Of course, before you leave the video, hit the like button, turn on the post notification bell. I do post contents on a weekly basis, and of course this is to help you to become a stronger student. So until then, take care. I'll see you in the next tutorial. Bye bye.